Once again, a very good afternoon to all of you, my dear children. Okay, warm welcome once again to our beautiful study channel, that is Perry's Study and Motivation. Okay, so yesterday we have learnt about certain concepts from the topic of chemical reactions and equations. Okay, in previous video we have learnt part 1 of chemical reactions and equations chapter. Okay, in that we have covered types of chemical changes. Okay, in that first type of reactions are what? Chemical combination reactions. We have covered chemical decomposition and chemical displacement reactions with certain examples we have covered. Okay, so in today's video we are going to learn about the remaining types of chemical reactions. Okay, that means here in this video we are going to learn about chemical reactions part 2, chemical reactions and equations. Okay, now chemical reactions and equations part 2. Okay, so in this video we are going to discuss about concept overview. In third part of this lesson, okay, we will be discussing all about the different kinds of objectives that are expected to come for competitive exams. Okay, most of the children has to focus on certain objective type questions for attempting certain competitive exams like triple IT, okay, Polycet, okay, whatever the competitive upcoming competitive exams whichever are there. Okay, you have to focus on the concept as well as what kind of questioning you will be getting. Okay, that questioning also we will be learning in this video. Okay, not only in this video, even in part 2 also, part 3 also. Okay, so let us go for the remaining topics which we have to learn from part 2 of this lesson. Okay, so in this video we are going to cover about chemical double decomposition reactions. Fourth type of chemical changes, chemical double decomposition reactions. Okay, you can even call them as what? Chemical double displacement reactions. Okay, chemical double decomposition reactions. And also we are going to cover certain reactions like corrosion reactions are there, which are occurring in our daily life, corrosion. Okay, and we will also cover up with certain redox reactions also. What are redox reactions? Okay, we are going to cover up certain redox reactions, and we also will discuss certain examples for exothermic and endothermic reactions. Okay, so with this we will be completing with types of chemical changes or types of chemical reactions. Okay, so let us move on to the first one in this, chemical double decomposition reactions. Okay, so in this chemical double decomposition reactions, mutual exchange of radicals takes place. Okay, now mutual exchange of radicals means ions gets exchanged. Okay, now ions, they get interchanged with each other, so that 2 times splitting of a compound takes place 2 times, and we are going to get 2 different newly formed compounds also. Okay, so chemical double decomposition reactions, in this what will happen mainly is mutual exchange of radicals takes place. Okay, now mutual exchange of radicals, ions. Okay, this is what you will observe in chemical double decomposition reactions. Okay, so here these chemical double decomposition reactions are again classified into 2 types. Okay, they are what? Precipitation reactions and neutralization reactions. Okay, precipitation reactions and neutralization reactions. Okay, so what are precipitation reactions? The reactions in which they form precipitate. Aqueous solutions of 2 salts are mixed with each other, so that it results in the formation of what? An insoluble solid substance, which is, in other words, we call it as what? Precipitate. Okay, an insoluble solid substance which settles down at the bottom of the test tube. You call it as what? Precipitate. Okay, so precipitation reactions are formed. These precipitation reactions are formed when two or more two aqueous solutions of salts. Okay, not aqueous salt solutions. Okay, aqueous salt solutions are mixed. Then you will get an insoluble solid substance which settles down. Okay, precipitate is formed. PPT. In short, we will say PPT. PPT means what here? Precipitate. Precipitate is formed. Okay, such reactions you call them as what? Precipitation reactions. Okay, so what are the different examples for precipitation reactions? You have to learn certain examples. Okay, and you have to remember even the color changes which you are going to get in this precipitation reactions. Okay, so let us learn about certain examples. Okay, so you all know that lead nitrate. Example 1 you can take lead nitrate. Okay, PbNO3 taken twice which means what? Lead nitrate. Okay, when reacts with potassium iodide Ki, okay, it gives rise to PbI2. PbI2, which is considered to be the precipitate which is formed in this reaction, and along with that you will be produced with KNO3 also. Here lead iodide is the precipitate which is formed. This is the insoluble solid substance which settles down at the bottom of the test tube. Okay, so lead iodide will be a yellow colored precipitate. Okay, yellow colored precipitate it is, lead iodide. Okay, so this is an example for what? Precipitation reaction. Okay, one of the double decomposition reactions. Here lead and nitrate got separated with each other. Even K and I also got separated with each other. Okay, lead is forming a compound with iodine and it is given by PbI2. Lead iodide is formed, and potassium mixed with nitrate ion of lead and forms separately potassium nitrate is also formed. So like that mutual exchange of radicals takes place. That's why this is an example for what? Double decomposition reaction. Okay, next we will see some more examples. Second example, here you will be asked for color changes, so you have to by heart certain examples. Okay, see here FeCl3, ferric chloride. Okay, aqueous solution of ferric chloride when reacts with aqueous solution of NaOH. Okay, now sodium hydroxide. Ferric chloride when reacts with sodium hydroxide, you will get FeOH taken thrice, which is FeOH taken thrice, which is considered to be the precipitate which is formed. Okay, plus NaCl. Here you have to keep 2 NaCl. Okay, so here the precipitate formed is what? FeOH taken thrice. Okay, FeOH taken thrice, and this precipitate will be considered as what? Dirty green colored precipitate. You generally term it as what? In chemistry terminology, you will call it as dirty green precipitate. It's not that the precipitate is a dirty one. No, dirty green precipitate you call it as. Okay, so that is an example for precipitation reaction. Remember the color changes. Okay, now, and next BaCl2 when reacts with H2SO4. Barium chloride. BaCl2 means what? Barium chloride when reacts with H2SO4. It forms what? Barium sulfate plus HCl. Okay, now barium sulfate plus 2HCl. So here barium sulfate is the precipitate formed. Here barium sulfate is what? White precipitate. White precipitate which is formed when you take aqueous solution of barium chloride, okay, and aqueous solution of sulfuric acid. Okay, you will get what? White precipitate of barium sulfate. Okay, and next you have copper sulfate when reacts with NaOH. Okay, CuSO4, copper sulfate you have to take always aqueous solutions. Okay, when reacts with NaOH, okay, this is also aqueous solution you have to take. It gives rise to CuOH taken twice. Okay, CuOH taken twice, which is considered to be the blue precipitate. Okay, now bluish precipitate you will get, and along with that Na2SO4 also we will be getting. So in all these cases you are observing colored precipitates are being formed. So you have to remember the color changes also, so that it will be very much beneficial for you for your competitive exams. Okay, so these all reactions comes under what? Precipitation reactions. Okay, and next we have to go for neutralization reactions. What are neutralization reactions? Okay, acid and base gives rise to salt and water. Such reactions are called as what? Neutralization reactions. Reactions in which acid and base react with each other to form salt and water. Okay, neutralization. You call it as what? Neutralization. Acid plus base gives rise to salt plus water. This is the general equation for neutralization reaction. Okay, so here you can take the example of an acid. A well-known example is HCl. Okay, and then reacts with a base. Okay, NaOH, sodium hydroxide, the first basic substance which we will be learning about, isn't it? So HCl reacts with NaOH to give NaCl, which is considered to be common salt, plus water. Okay, so this reaction is called as an example for what? It's an example for neutralization reaction. Okay, so here you have taken strong acid and strong base, and the so formed salt is considered to be a neutral salt. Please remember, if you take strong acid and strong base, okay, HCl is strong acid, NaOH is strong base. Okay, NaOH is strong base. Okay, then you will be getting what? Neutral salt. NaCl is what? Neutral salt. Okay, so and along with that, here along with the products, even 13.7 kilocalories of heat is also liberated. That means what? Neutralization reactions are exothermic reactions. Okay, after the formation of salt and water, 13.7 kilocalories of heat is liberated. Okay, which means what? Neutralization reactions are exothermic reactions. So you have to remember that point. Okay, suppose if you take any of the substances, either of acid or base, to be weak. Okay, like if you take HCl, here we have taken strong acid. Instead of strong acid, I am taking weak acid like CH3COOH, which is what? Acetic acid. Okay, now acetic acid is organic acid. Acetic acid. Okay, it's a weak acid. It reacts with the strong base NaOH. Then it also forms salt and water only. CH3COONA plus H2O. What is this substance which is so formed salt? It is sodium acetate. Okay, now sodium acetate. So sodium acetate is formed by acetic acid and NaOH. Okay, here the base is strong. Okay, acid is weak. So if you take strong base and weak acid, okay, then the so formed salt is considered to be basic salt. Sodium acetate is basic salt. Okay, now please remember, sodium acetate is what? Basic salt. Okay, so here also some amount of heat energy is released, but here you will observe only 13.4 kilocalories of heat only is released. The difference amount of heat, if you compare from the first reaction to second reaction, 0.3 kilocalories of heat is used up in case of for neutralizing this weak acid. Okay, now for neutralizing this weak acid, 13.4 kilocalories only released. That means that extra 0.3 kilocalories of heat is getting used up in order to ionize that weak acid. Okay, now because it is weak, it cannot get ionized quickly, so it requires some amount of heat. Okay, that's why the heat released here, also heat released only, but still the amount of heat released is less comparatively than the case 1. Okay, so like this you have certain neutralization reactions in which what acid and base gives rise to salt and water. We'll take one more example where you will take acid to be strong and base to be weak. NH4OH if you take, weak base, strong acid, weak base. Okay, now strong acid reacts with what? Weak base. Then it gives rise to salt. Here NH4Cl is a salt which is formed plus H2O. Okay, here also salt and water only will form, but still here NH4Cl, ammonium chloride, is what type of salt it is? Acidic salt. Okay, because the acid taken is strong and the base taken is weak. Okay, so the resultant salt, the so formed salt, is considered to be what? Acidic salt. Here ammonium chloride, NH4Cl means what? Ammonium chloride is an acidic salt. Okay, so like that you have neutral salts will be there, basic salts will be there, and even acidic salts also will be there. Okay, so these all types of reactions comes under what? Neutralization reactions. Please remember this point. Okay, so you have we'll move on. So these two categories comes under what? Chemical double decomposition reactions. Okay, so next we will be moving on to second types of reactions which we have to discuss, that is about corrosion reactions. Okay, second type of reactions in this like in this today's class is about what? Corrosion reactions. What is corrosion? Corrosion means what? Like for iron articles gets rusted, you all know that. Okay, so what happens over there? Formation of an unwanted oxide layer on the surface of metals. Okay, when they are exposed to what? When they are exposed to atmospheric oxygen, okay, metals get corroded. Means what? An unwanted oxide layer will form on the surface of that metals, and that unwanted layer only you are calling it as what? Corrosion. Okay, that spoils the metal. Okay, so here corrosion reaction means what? Formation of an unwanted oxide layer. Formation of an unwanted oxide layer. Okay, or you can even define it as what? Eating away of metals by atmospheric oxygen is called as corrosion. Unwanted here what? Oxide layer. Okay, when metals are exposed to atmospheric oxygen, when metals are exposed to atmospheric oxygen, they get corroded. Okay, so such reactions are called as what? Corrosion reactions. Okay, so here you have certain types of corrosions are there. First one is rusting of iron. Okay, now rusting of iron is there. Okay, and then you have tarnishing of silver is there. Tarnishing of silver, tarnishing of copper. Okay, these all comes under what? Corrosion reactions only. Tarnishing of silver and tarnishing of copper. So formation of rust, rusting of iron. See, when iron articles are exposed to atmospheric oxygen, okay, they get rusted. Okay, so there forms what? Unwanted oxide layer. So Fe plus 3O2, 4Fe plus 3O2 gives rise to 2Fe2O3. Okay, here some X water molecules are being absorbed from the atmosphere. From the atmosphere, certain water molecules are being absorbed by iron articles. Okay, so depending on the amount of water molecules that are absorbed, okay, number of water molecules will be decided. So Fe2O3.XH2O is the general formula for rust. Okay, now rust, it's a general formula for rust. Okay, so this is corrosion reaction. Rusting of iron is called as what? Corrosion reaction. Okay, same like that other metals like copper, okay, silver. What happened to them when exposed to atmospheric oxygen? They also get corroded. Okay, so this example is for rusting of iron. Same like that, if you go for second type of example, tarnishing of silver. Okay, now tarnishing, silver articles also gets corroded. Okay, the silver articles which we use in our puja room. Okay, in our puja room we use so many silver articles. Okay, if it is any occasion is there, or if any puja is there in our house, okay, we'll use silver articles. And you might have observed, if we are keeping that silver articles in our shelf, okay, you will find the formation of oxide layer on it, which is appearing to be brown in color on the surface of that silver articles. Okay, brown color coating you will observe, which is nothing but corrosion only, means tarnishing only. That means unwanted oxide layer is formed. Instead of saying oxide layer, here silver mainly reacts with atmospheric H2S gas. What is H2S here? Hydrogen sulfide gas. The gas which is present in drainage water or wherever stagnant water, if it is there you will find the formation of H2S gas. What is H2S? Hydrogen sulfide gas. Okay, now hydrogen sulfide. So this Ag, when reacts with H2S, it forms Ag2S. This is silver sulfide, which is considered to be what? The unwanted oxide layer which is formed. Okay, the unwanted oxide layer. Here it is sulfide layer, brown colored sulfide layer is formed. Okay, plus H2. Liberation of hydrogen is very less. Okay, but still, okay, hydrogen sulfide gas, it's having rotten egg smell. Sometimes in objectives you will be asked, the gas with rotten egg smell is what? H2S gas. Okay, which is generally produced near drainages or wherever stagnant water is there it starts getting reproduced. Okay, so silver articles reacts with that H2S gas and they get corroded. Okay, this is called as what? Tarnishing of silver, right? And same like that you will be finding out tarnishing of copper articles also. Okay, you might have seen most of the students nowadays, they are using what? Copper water bottles. Okay, in our schools we are finding so many children are using copper water bottles, healthy, okay, copper charged water children are drinking. Okay, based on that copper charged water, they will cause many health benefits. Okay, many people are becoming health conscious nowadays, isn't it? So you will find if we don't scrub that copper water bottle, you will find the formation of an oxide layer on that copper water bottle. Okay, so that will be appearing in green color. Okay, some green colored coating will be formed. Okay, third type of reactions are what? Tarnishing of copper. Tarnishing of copper articles. Okay, so copper articles when exposed to air, okay, atmospheric oxygen, if they are exposed, it forms first of all a black colored copper oxide will form. Okay, now 2Cu plus O2 gives rise to 2CuO, which is generally black in color. This copper oxide, okay, when reacts with atmospheric carbon dioxide, it forms what? Copper carbonate, CuCO3 is formed. This will be bluish green in color. Okay, copper carbonate is what? Which colored? Bluish green in color. And that CuCO3, even suppose that CuO, when made to react with atmospheric moisture, okay, here water I wrote, but still it is what? Moisture. Okay, if it is exposed to atmospheric moisture, then it gives rise to what? CuOH taken twice, which is appearing like a green coating on the surface of copper articles, green coating. Okay, so copper hydroxide will form on the surface of what we call, on the surface of metal, copper metal. Okay, so these all colored substances which are being formed as an unwanted layer on the surface of copper articles. You call that phenomenon as what? Tarnishing of copper. Okay, so here this is a chemical reaction, okay, which is happening in our daily life also. Okay, so corrosion comes under daily life reactions which we are seeing in our day-to-day life, right? Okay, then we go for certain other type of reactions, like what? You have certain other types of reactions like reversible and irreversible reactions are there. Okay, once look at this area also, irreversible and reversible reactions. Reversible and irreversible reactions. So in the name itself it is there. Irreversible means what? Reactants can be converted into products, but products cannot be converted back to reactants. Then such kind of reactions are called as what? Irreversible reactions. Okay, let us learn some examples for irreversible reactions, means which cannot be reversed. Okay, for irreversible reactions, certain examples we have to learn. Okay, so examples are what? Decomposition reactions, thermal decomposition reactions like 2KClO3. On heating, it gives rise to what? 2KCl plus 3O2. Okay, 2KCl plus 3O2. This is an example for thermal decomposition reactions. Thermal decomposition reactions can never be reversed. Okay, same like that. This is an example for what? Thermal decomposition. Please remember, we have learned this even there also. So thermal decomposition reactions are irreversible reactions. This is first example you can take. Similarly, for irreversible reactions, you can take combustion reactions. Combustion reactions. You know what are combustion reactions? Reactions in which happens in presence of excess of oxygen. Okay, combustion means burning of any substance in excess of oxygen. You call it as what? Combustion. Okay, burning of any substance in excess of oxygen is called what? Combustion reactions. Okay, burning of any substance in excess of oxygen, you call it as combustion reactions. Okay, so like you can take the example of burning of fuels like CH4. It's a natural gas, methane. Its name is what? Methane. When combusted with oxygen gas, it forms CO2 plus H2O. The standard products that are formed whenever any combustion of fuels takes place, you will observe the formation of standard products. What are those? Carbon dioxide and water. They are fixed products. Whenever any hydrocarbon is combusted, the fixed products which you are going to get are what? CO2 and H2O. Okay, so like this, combustion reactions are also irreversible reactions which happens only one-sided reactions. Means what? Reactants converts to products, but products can never be converted back to reactants. Okay, such kind of reactions are called as irreversible reactions. Okay, you can take other examples like precipitation reactions, neutralization reactions. All those are what? Irreversible only. Okay, and if you go for reversible reactions, means reactants can be converted into products, and products also can be converted back to reactants. Such kind of reactions are called as what? Reversible reactions. So here we have to study certain examples for reversible reactions. So first and best example is what? N2 plus 3H2 gives rise to 2NH3. This is formation of ammonia. Okay, now ammonia by Haber's process. Okay, ammonia, synthesis of ammonia is an example for reversible reaction. Okay, same like that, H2 plus I2 gives rise to 2HI. Okay, hydrogen plus iodine. I2 stands for what? Iodine. It gives rise to hydrogen iodide, 2HI. It's a reversible reaction. Even you can take the example of PCl3 plus Cl2 gives rise to PCl5. Okay, reversible reaction. And you can even take the example of contact process. SO2 plus SO3 plus H2O gives rise to H2SO4. It's also a reversible reaction. And you have lot many examples. N2 plus O2 gives rise to 2NO. Okay, 2NO. So this all comes under what? Reversible reactions. Examples for reversible reactions. So many examples you will be having like this. Okay, same like that you have next set of reactions which we have to learn about are what? Yes, exothermic and endothermic reactions. Exothermic reactions means the reactions in which heat energy is released. Okay, the reactions which are associated with release of heat energy. Okay, exothermic reactions. Exothermic means what? Release of heat energy. The reactions which are associated with what? Release of heat are called as exothermic reactions, and the reactions which are associated with absorption of heat energy, you call them as what? Endothermic reactions. Absorption. Endothermic stands for what? Absorption of heat. Okay. Heat, if it is absorbed, then you call them as what? Endothermic. The word thermal energy stands for what? Heat energy. Okay, so exothermic reactions, you have lot many examples. Most of the reactions which we come across comes under exothermic reactions only. Okay, lot many examples. Whatever just now we have learned, neutralization is an exothermic reaction. Okay, NaOH plus H2O, sorry, HCl gives rise to NaCl plus H2O plus 13.7 kilocalories of heat is released. So it's an example for what? Heat is released. Means what? Exothermic reactions. Okay. Same like that you have burning of fuels. If you take, lot much heat energy is liberated. Okay. So you can take wherever heat liberation takes place. C plus O2 gives rise to CO2 plus heat energy. Okay. Same like that S plus O2 gives rise to SO2 plus heat energy. Okay. And whenever any metals reacts with acids, okay, then it gives rise to certain metal salts plus hydrogen gas will be released, and along with that heat energy is also released, which all comes under what? Exothermic reactions. Means what? Reactions in which heat energy is released. Okay. Even formation of ammonia, as I said you, it is also an exothermic reaction. N2 plus 3H2 gives rise to what? Gives rise to 2NH3. It's also an exothermic reaction. Then what are the examples of endothermic reactions? Where heat energy is absorbed. Examples for endothermic reactions. Okay. Examples for endothermic reactions. Okay, so you can take the example of N2 plus O2 gives rise to 2NO. N2 plus O2 plus heat energy, then only it gives rise to 2NO. Okay, it's an endothermic reaction. Reactants require some heat energy in order to form the product. Newly formed product is what here? Nitric oxide. Okay, so N2 plus O2 plus heat gives rise to NO2, 2NO. Okay, C plus H2O gives rise to C plus H2O gives rise to CO plus H2. CO plus H2. Here also you need to supply some amount of heat to this carbon solid to react with water. On heating, it gives rise to carbon monoxide and hydrogen. It's also an example for endothermic reaction. Okay, dissolution of glucose in water. Dissolution of glucose in water. Of course, it's a physical change. Okay, now glucose in water. You will observe the test tube becomes cool. Okay, if you are dropping one spoonful of glucose in normal water. Okay, if you observe, if you touch that glass in which glucose is dissolved, if you touch that, you will feel that to be very cool. Okay, such reactions, okay, it comes under endothermic reactions. That means they absorb heat from the surroundings, okay, and they get cooled. Okay, so that is such kind of reactions comes under what? Endothermic reactions. Okay, and finally you have another category are also there, another category of reactions are also there, which are called as what? Redox reactions. Okay, you have last category which are called as what? Redox reactions. Okay, redox reactions. So what are redox reactions? In the name itself it is there. Reactions in which both oxidation and reduction takes place simultaneously. Okay, so what is oxidation and what is reduction? Oxidation, you have lot many definitions, like loss of electrons is oxidation, or addition of oxygen is also an oxidation reaction, addition of oxygen, and removal of hydrogen is also an oxidation reaction, removal of H2. Similarly, reduction means what? Gain of electrons is called reduction. Okay, addition of hydrogen, addition of H2, and removal of O2 is termed as reduction reactions. Okay, and the substance which undergoes oxidation is called reducing agent. Substance, okay, now which undergo oxidation, substance which undergo oxidation are called what? Reducing agents. Please remember, reducing agents. Substances which undergo reduction are called as what? Reducing agents, whereas substances which undergo oxidation are called reduction are called oxidizing agents. Substances which undergo, okay, now which undergo reduction are called oxidizing agents. Okay, they are called as what? Oxidizing agents. Okay, generally if you go for metals are considered to be best reducing agents. Please understand the point carefully. Okay, we'll see certain examples for redox reactions also. Okay, redox reactions. Okay, certain reactions, let us take an example. Okay, 2Mg plus O2 gives rise to 2MgO. This reaction is there. Here magnesium is added with oxygen. Okay, so magnesium converted into its oxide. Okay, so it is oxidized. Okay, magnesium is oxidized to MgO. Please understand the point carefully. That's why magnesium is treated as reducing agent. Here what is oxidized? Means what you will say? Magnesium is oxidized. To what? Means magnesium oxide. So substances which undergo oxidation, magnesium is oxidized. So magnesium is treated as what? Reducing agent. Okay, and that too, magnesium is a metal. You can take this as an example. And oxygen is removed. So oxygen gets reduced. Magnesium is oxidized. Okay, magnesium is oxidized. Oxygen is reduced. Okay, so here this is an example for what? Redox reaction. Okay, and you can take C plus O2 gives rise to CO2. Okay, here carbon is added with oxygen. Okay, so carbon is oxidized. Carbon is oxidized. Okay, so carbon is considered to be what? Reducing agent. Carbon is oxidized. So carbon is said to be reducing agent, and oxygen is said to be oxidizing agent. Please understand the points carefully. Okay, so in any reaction, which substance is oxidized, which substance is reduced, like that you will be getting certain questions. Okay, once look at this reaction. In this reaction, N2 plus 3H2 gives rise to 2NH3. N2 plus 3H2 gives rise to 2NH3. Here oxygen not there, but instead of oxygen what you have? Hydrogen is there. Addition of hydrogen is called what? Reduction. Okay, so nitrogen is undergoing reduction. Okay, so nitrogen is undergoing reduction. So nitrogen is said to be what? Oxidizing agent. Oxidizing agent. Whereas hydrogen is said to be what? Reducing agent. Okay, hydrogen is said to be reducing agent. Nitrogen is said to be what? Oxidizing agent. Okay, so like that any reaction if it is given to you, you can easily identify which is getting oxidized and which is getting reduced. Okay, actually you have oxidation number method is a relevant method to identify which is getting oxidized and which is getting reduced, like that. Okay, I'll just give you one more example. 2AgNO3 gives rise to 2AgNO3 gives rise to 2Ag plus 2NO2 plus O2. 2NO2 plus O2. Here what happened to AgNO3? Okay, once look at this. AgNO3 is turning into simple Ag only. That means it is reduced. Ag is reduced to AgNO3 is reduced to Ag. Okay, please understand the point carefully. AgNO3 is reduced to Ag. Okay, so AgNO3 in that Ag is called as what? Substance which is reduced is called as what? Oxidizing agent. Okay, so here like that you have to identify certain reactions. Okay, so like this. And you have certain methods to prevent corrosion. I forgot to discuss about that. What are the different methods to prevent corrosion? Okay, what are the different methods to prevent corrosion? Methods to prevent corrosion. What are the different methods? Yes, you have oiling, painting, greasing. All these are general normal methods. Oiling, painting, greasing, general methods. You are applying grease so that corrosion gets reduced. Okay, so general methods are these. And you have another method called as what? Galvanization. Galvanization means what? Coating of metal articles with zinc. Coating of metal articles with zinc. You call it as what? Galvanization reaction with zinc coating. Okay, like you are observing nowadays, bridges, railings of bridges are coated with zinc only, so that even how much ever they are exposed to atmospheric oxygen, they never get corroded. Okay, now bridges, Godavari bridge, you might be seeing railway bridges, they are made. Okay, they are coated with what? Zinc coating. Okay, and that process you call it as what? Galvanization. So by coating any metallic substance with zinc, it reduces corrosion, it avoids corrosion. Okay, so galvanization is one method. And next we have alloying is there. Alloying, mixing of two or more metals to give two or more metals to give a bright finish or to improve the properties of that metallic substance. We add two or more metals. Okay, and that process you call it as what? Alloying. You can easily remember that bronze. Bronze is an alloy of what? Bronze is an alloy of copper plus tin. Cu copper, Sn means what? Tin. Copper plus tin. Okay, so the so formed newly substance is called as bronze. Okay, so that by adding these two substances, the individual qualities of copper as well as tin also gets improved. Quality is improved. Okay, so bronze, you can get this. And brass is an alloy of copper and zinc. Alloy of copper and zinc. Okay, like that you have lot many alloys are there. Alloying is done to prevent methods of, it's one of the preventing methods of corrosion. Okay, you can reduce corrosion by alloying process. And finally you have electroplating. Okay, electroplating means what? Coating of superior metal over an inferior metal is called as what? Electroplating. That means coating of, like gold coating. Coating of gold on copper. Copper is a cheap metal, gold is costly metal. Okay, so gold is called as what? Superior metal, whereas copper is considered to be what? Inferior metal. Okay, coating of superior metal over an inferior metal, that process you call it as what? Electroplating, by passing electricity through it. Okay, so these are the different methods to avoid what? Corrosion reactions. Okay, so like this, all types of chemical reactions you have observed. Okay, we have covered up all the different types of chemical reactions. Okay, so along with this, you have a small topic of the concept of mole also has been introduced in this lesson. Okay, as a small topic of concept of mole. Mole, what does it mean? What is it? What does it mean? It's not the mole which is there on our hands or on our legs or on our body. No, not that mole. Mole means what? It has three types of interpretations are there. Okay, that means it has three different meanings are there. A mole can be defined as in terms of weight. In terms of weight, a mole, 1 mole of any substance is equal to its gram molecular weight. Okay, in terms of weight, 1 mole of any substance is equal to what? Gram molecular weight. GMW means what? Gram molecular weight. And 1 mole of any substance in terms of particles. Okay, in terms of particles present inside them, it is equal to what? Avogadro number. What is Avogadro number? Avogadro number is 6.023 into 10 to the power of 23. Okay, this number is called as what? Avogadro number. 6.023 into 10 to the power of 23 particles is there. 23 particles are there in 1 mole of any substance. Okay, now in 1 mole of any substance, how many particles will be there? 6.023 into 10 to the power of 23 particles will be there. So in terms of particles, 1 mole of any substance is equal to its Avogadro number. And third interpretation is what? In terms of volume. Okay, now in terms of volume, 1 mole of any substance occupies 22.4 liters of volume. Okay, 1 mole of any substance occupies how much? 22.4 liters of volume. Okay, so these are the three interpretations which you have to remember. Okay, if 1 mole of any substance, weight of 1 mole of any substance, if it is asked, you have to calculate gram molecular weight of that element or gram molecular weight of the given compound. Okay, that will be for 1 mole of the substance only. In terms of particles, it is equal to what? Avogadro number. And in terms of volume, it is equal to 22.4 liters. Okay, so like that, mole is also, concept of mole is also introduced. Just it is introduced. Okay, and there is a small formula to find the number of moles of a given compound. Okay, to find the number of moles. Okay, there is a small formula to find the number of moles. Okay, to find the number of moles, what formula we have? Number of moles denoted by the letter small n N is equals to given weight by gram molecular weight. Given weight of any substance by gram molecular weight of the substance gives you number of moles. Like for example, you can find the number of moles. Find the number of moles present in. Find the number of moles present in 10 grams of CaCO3. Like that, you are given one question. Then how you will write? Okay, solution. Given weight is how much? 10 grams. Okay, given weight is, given mass or given weight is how much? 10 grams. Gram molecular weight, GMW, is how much? Gram molecular weight of CaCO3. You have to remember the atomic masses of elements from 1 to 30. Okay, then you can it can be easily calculated. Okay, you have to remember calcium is 40, carbon is 12. Here one calcium is there, so 40 into 140. One carbon atom is there, 12 into 112. And oxygen is what? 16. And 3 oxygen atoms are there, so 16 into 3, 48. If you add all those things, what you will be getting? 100. So gram molecular weight of CaCO3 is how much? 100. So number of moles, N is equals to what? Small w by capital M. Here small w is given as 10 and capital M means molar mass we got it as 100. So answer is 1 by 10 means 0.1 moles. 10 grams of CaCO3 means how many moles? 0.1 moles. Okay, 100 grams of CaCO3 means 1 mole. 10 grams of CaCO3 means 0.1 moles. 100 is for what? Calcium carbonate's gram molecular weight. What you have learnt? In terms of weight, 1 mole of any substance is equal to its gram molecular weight. Okay, so here 100 grams is for gram molecular weight for 1 mole of CaCO3. Okay, so like that you have to check, and you have little bit of numericals also will be there based on this concept. We will be learning about that, all numericals and objective questions which you will be getting from this chapter. Everything, way of questioning, what type of questions, X, Y, Z questions, and different types of questions that are coming out from this chapter. We will be learning that in the next coming video. So I request all the students to make notes of what all your teacher says. Keep writing and practicing. Okay, I always say, what is my routine dialogue? Yes, I always say, your hard work is your superpower. So please keep learning, make notes of what all you have learnt. Happy learning. Thanks for watching. Bye.